In this video, we are going to see cross ratio of 4 points. So let us take 4 points in the z-plane as z1, z2, z3, z4. Then the cross ratio of 4 points can be written like this. That is z1 minus z2 into z3 minus z4 divided by z1 minus z4 into z3 minus z2. If we write all these 4 points in this ratio form, then this is called as cross ratio of 4 points. So based on this cross ratio of 4 points, we can have one property in the bilinear transformation. That is, the cross ratio of 4 points is invariant under bilinear transformation. So what do you mean by invariant? Invariant means there is no change. So here we are taking cross ratio of 4 points for both z plane as well as the w plane. So this is for w plane and this is for z plane. Since it is invariant under bilinear transformation, we can able to equated, right? Both are same. So we will be having this property. So based on this property, now we are going to see the below problem. That is, find the bilinear transformation which maps the points infinity comma I comma 0 onto 0 comma I comma infinity respectively. That is, here we are given 3 points, but for using cross ratio property we need 4 points, so that we have to include z as one point for the z plane and w as another point for the w plane. So that we will be having 4 points, so that we can apply the 4 points in this cross ratio property, and if we simplify this, we'll be getting the bilinear transformation. So now let us move on to the solution part. So here we have to consider the cross ratio property. So this is a cross ratio property. So let us take the 4 points as what is that? Bilinear, which maps the points this onto this, means this is the point we have to take it from for the z plane, and this is the point we have to take it for the w plane, that is z onto w, which means that we have to consider the 4 points as z comma infinity comma I comma 0, right? And then for w plane, it should be considered as w comma 0 comma I comma infinity. So here we have taken the fourth point as z here for the z plane and w for the w plane. So now we have to consider these are the 4 points for z plane and these are the 4 points for w plane. So it is not mandatory to choose the first term as z and w. If we want, we can also take it in between anywhere, or at last also we can take, but this order should not be changed. We should not shuffle the points. Okay. So here let it be Z1, Z2, Z3, Z4. Similarly here W1, W2, W3, W4, or otherwise for our convenient we can denote like this, Z4. Similarly W1, W2, W3 and W4. Now we have to put it in the given property or formula, right? While putting it in the formula here, if we notice here we are having one of the point as infinity. So we can't able to directly put it as infinity. So 1 by infinity is equal to 0, as we know already. So here, since z2 takes the value as infinity, what we can do here is we can take this right side. If we take z2, we have to take outside. So from the first term, if we remove z2 outside, we can write like this, the first factor. Similarly, there is no z2 in the second term, so we can write as it is. So divided by, similarly here z1 minus z4 is there, but in the next term we are having z2. So take z2 common, so z3 by z2 minus 1 we can write. So what happened here? We can cancel this z2 and this z2. Right. Similarly, we can do it for W. So W means here W4 takes the value infinity. So where we are having W4, here we are having W4. So how to write it? W1 minus W2. Here you take W4 outside. So W3 by W4 minus 1 we can write. So divided by, again in the denominator, if you take W4 outside, it becomes W1 by W4 minus 1 will be the first term. Next will be as it is, W3 minus W2. So what happened here? W4 and W4 get cancelled. Right. So what happened? This W3 by W4 can be substituted as 0, because since W4 is infinity, 1 by W4 will give you 0. Similarly, this term will become 0. Similarly, here Z1 by Z2 term will become 0. Similarly, Z3 by Z2 will become 0. So now for the remaining terms, we can substitute the remaining points. If we substitute the points, W1 is what? W1 is W minus W2 is 0 into, already it is 0, so simply minus 1 divided by W1 W4, again 0 minus 1 is minus 1 by W3 is I, W2 is 0, so it becomes I minus 0. Similarly here what happened? 0 minus 1 is minus 1. Z3 minus Z4. Z3 minus Z4 is I minus 0 divided by Z1 minus Z4 is Z minus 0 into minus 1. So if we simplify this, so let me simplify this. So here minus 1 get cancelled, minus 1 get cancelled. Here we are left with the W, denominator is I, which is equal to here I divided by Z. So simple. So finally, W can be written as this I, if you cross multiply, it becomes I square by Z, which is equal to minus 1 by Z. Finally, W is equal to minus 1 by Z is the corresponding bilinear transformation for the given points. So we have to find out the bilinear transformation. It should be in the format AZ plus B by CZ plus D. Always you have to give W as function of Z. Right? This is called as bilinear transformation. Now if you notice this here, actually what do you mean by this is Z, that is denominator Z represents, here C coefficient is 1, D 0. Similarly, in the numerator, A becomes 0 and B takes the value minus 1. That is a meaning. Okay. So, this is called as bilinear transformation for the given points. Let us see the second question. Find the bilinear transformation which maps the point 0, 1, infinity onto I, minus 1, minus I respectively. So already we know the cross ratio property. So this is the cross ratio property. So as usual, we can consider the points as z, 0, 1, infinity are the 4 points, and then w, I, minus 1, minus I are the 4 points in the w plane. So now let us apply it in the formula here. So it gives you, first we are substituting the w points, so that w minus I, that is w1 minus w2, w3 minus w4. So minus 1, minus of minus I is plus I, divided by w1 w4. So it becomes w plus I, and then w3 minus w2. So this is equal to z1 minus z2, and then here 1 minus 0 we can write. Sorry, 0 minus 1. Right, because here z4 takes the value infinity, so that here in the numerator it will be taking z4 common, so z3 by z4 minus 1 divided by, in the denominator if you take z4, it will be z1 by z4 minus 1. So z4 cancels, so this becomes 0 here minus 1. Similarly, in the denominator, 0 minus 1 again into Z3 minus Z2, that is 1 minus 0. Z3 is 1, Z2 is 0. So this is what we are getting. So if we see here in the right side term, minus 1 get cancelled, this becomes 1, so totally it is Z alone. In the left side we are having Z in the right side we are having this term. So what we can do here is we can take minus from these two terms and we can cancel it. So we can write it as like this. Is equal to z. But actually what we have to do is we have to find the transformation w is equal to f of z. We don't want w z equal to function of w. We want w as a function of z. So we have to simplify further. So to simplify this, we can multiply and divide by its conjugate. So first let us write the given term. So what is the conjugate to this complex number is 1 minus I is the complex conjugate to this 1 plus I. So we are multiplying dividing by 1 minus I. Okay, is equal to Z. Now we have to simplify this. If we simplify this, actually this and this we can multiply. Similarly in the denominator also we can multiply. If we multiply, we will get W minus I into minus 2I divided by W plus I into 2. That is, if we multiply these two complex numbers and these two complex numbers, we will get these two terms. So here again 2 get cancelled, which is equal to Z is the right side term. So now what we are going to do with W minus I by W plus I is equal to Z by minus I. That is, this minus I can be taken to the right side as a denominator term. Now this term we have to simplify to get what is W. Since we are having both the numerator and denominator having W here, we can use one property called as componendo dividendo rule because it is in the cross ratio form. So what is that componendo dividendo rule? Componendo dividendo rule is nothing but whenever there is a ratio A by B is equal to C by D, the componendo rule is A minus B by A plus B should be equal to C minus D by C plus D. This is the componendo dividendo rule. So this rule we have to apply here so that what in the left side what we will have, this is A minus B. So minus W minus I, this is B, divided by denominator should be added. So plus W plus I is equal to, similarly here Z minus of minus I divided by Z plus I is minus I is Z. So I directly can put. So now what happened here is we can cancel this W. So numerator becomes minus 2I divided by, here I get cancelled, minus I and plus I get cancelled, here it becomes 2W. So this is equal to here Z plus I divided by Z minus I. Here finally we want only W. So we can have W, that is cross multiply that, divided by this comes here. So finally from the above step we will get W is equal to this. So if we multiply this I, inside this becomes minus IZ minus 1, because minus I into minus I is I square is minus 1 again. This divided by Z plus I. So this is the final answer. If we want, we can take minus common and we can write it as plus Z divided by Z plus I. So now this is the bilinear transformation for the given points.